Welcome to our second video on solving a system of linear equations using the elimination method. Ladies and gentlemen, please turn back in your notes to the very front page, and we are going to read again the steps for solving a system of linear equations. Because in our first video, we didn't have to do step one. We got to skip it every time. But this time, we need to do it. So we're going to reread step one. And step one says, multiply, if necessary, one or both equations by a constant so that at least one pair of like terms has the same or opposite coefficients. Recall, if we have the same coefficient, that means they are the same sign. The numbers will be the same, but to be the same coefficient, they have the same sign. If we have opposite coefficients, that means we have opposite signs. The numbers are still the same. The numerical factor of the coefficient is still the same. It's the signs that are opposite. And opposite signs are better because they allow us to actually add the two equations, which immediately lets us eliminate. If the signs or the coefficients are the same, then we have to subtract, which requires us to follow the integer rules and do the same change process. And I'm just going to tell you that the more we have to do, the more likely it is we're going to make a mistake. So we're going to set ourselves up. And I'm looking at this first equation. This example 5, 5x plus y equals 9, 10x minus 7y equals negative 18. Now there's a couple options that we have here. I'm just going to take us to one, and we're just going to do it. And if you want to see other options, by all means, please ask to see them in class. So I'm immediately drawn, this is just me, I'm immediately drawn to the y terms because I see that they're already, one of them is positive and one of them is negative. And it would be very easy to multiply the first equation by a positive 7 to create opposite y terms. So I have to use the distributive property because I have to multiply every single term to create an equivalent equation. 7 times 5, x is 35x. 7 times y is a positive 7y. And 7 times 9 is 63. Now, because I've created those opposite y terms, I can add to eliminate. 10x plus 35x is 45x. Negative 7y plus 7y, well, they are eliminated because they give us 0. And negative 18 plus 63 is 45. Now we need to isolate x by doing the inverse, dividing by 45. We do it to both sides to keep the equation balanced, and we realize that x is equal to 1. We put our 1, you know me, I like to make our ordered pair solution set right away, so the x coordinate is 1. I now will take that 1 and I substitute it into, I'm going to go to the first equation. It makes no difference which equation you use. And I'm going to go 5 times 1 plus y is 9. And that makes 5 plus y is 9. Subtracting 5 from both sides, we get y is equal to 4. So my ordered pair solution is 1, 4. I'm going to quickly double check that by putting that ordered pair into our second equation and saying 10 times 1 minus 7 times 4 is equal to negative 18. Well, that's 10 minus 28 equals negative 18, and 10 minus 28 is negative 18. So negative 18 is equal to negative 18. We are good to go. Moving on to our second example, 8x plus 14y equals 4, and negative 6x minus 7y equals negative 10. Again, we have some options here. We could multiply both equations by a constant so that we could eliminate our x terms. But again, I'm drawn to the y term. And when I go to the y term, I see that they are opposite signs, just like the x terms are. But 7 and 14 are compatible, where 8 and 6 are not. So in this case, I only have to multiply one equation instead of two. So again, I'm going to multiply by a positive 2, the second equation. And 2 times a negative 6 is negative 12x. 2 times a negative 7y is negative 14y. And 2 times a negative 10 is negative 20. Bringing down the first equation so that I can subtract so I can add real easily. And that would be a negative 12x plus 8x is negative 4x. Well, the negative 14y and the positive 14y are eliminated. And negative 20 and a positive 4 is negative 16. Again, isolating the variable, dividing by a negative 4, doing it to both sides, we realize that x is 4. So I can come over here and I put 4 in my x coordinate for my solution, my ordered pair solution. And then I take that 4 and I substitute it into either equation. I always like going to the first one. It really, again, makes no difference. 8 times 4 plus 14y equals 4. So 32 plus 14y equals 4. Subtracting 32 from both sides gives me 14y equals a negative 32. Dividing by 4 minus 32 is 28. So 14y equals a negative 28. And now when I divide by 14, I get that y is equal to negative 2. Well, I'm having a hard time on this one. Y is equal to negative 2. I put negative 2 in my y coordinate for my ordered pair solution. And then I can take that ordered pair solution, I can put it in the second equation, and I can say negative 6 times 4 minus 7 times a negative 2 is equal to negative 10. Negative 24 plus 14 equals a negative 10, and that is absolutely true, that negative 10 equals negative 10. Our last example for this video, in this case, we will have to multiply both equations by a constant, because 5x plus 4y equals a negative 30, and 3x minus 9y equals a negative 18. We do not have any x terms or y terms that are compatible. So we have to multiply by 2 terms. Now I recognize that my x terms are both positive and my y terms are opposite. We like those opposites. Well, I'm going to do something a little bit different on this one just to show you. I'm going to actually eliminate the x terms. So I'm going to come up here with the first equation and I'm going to multiply it by a negative 3. And you'll see why in a minute. You can always use your constant as negative. So negative 3 times 5x is negative 15x. Negative 3 times a positive 4y is negative 12y. And negative 3 times a negative 30 is equal to a positive 90. And then I'm going to multiply my second equation. I'm going to multiply my second equation by a positive 5. Positive 5 times 3x gives me a positive 15x. Positive 5 times a negative 49 is negative 45y. And then positive 5 times a negative 18 is negative 90. Now I can add these. Maybe you see why I did that. Because now I can eliminate a negative 15x and a positive 15x are 0. It's eliminated. Negative 12y and a negative 45y is negative 57y. And a 90 plus a negative 90, well, those are opposites, so they are also eliminated. They give us 0. Now, you might think that we did something wrong, but we really did not. We divide by a negative 57, and we get that y equals 0. You can have an ordered pair solution where one or both of the coordinates are 0. Let's put it in and let's find out and prove it. So now I'm going to take that 0 and I'm going to substitute it into the first equation for y, because y is 0. I have 5x plus 4 times 0 is equal to negative 30. Well, the 4 times 0 goes away, so 5x equals a negative 30. Dividing by 5, we find that x is equal to negative 6. So our ordered pair solution seems to be negative 6, 0. Well, we're going to prove it. And we're going to take that negative 6, 0, and we're going to put it into the second equation. And we're going to go 3 times a negative 6 minus 9 times 0 equals a negative 18. Well, 3 times a negative 6 is negative 18. Negative 9 times 0 is 0, and that is equal to negative 18. So it all works out just perfectly. Negative 6, 0. Be confident in your answers. I do not have a quick write for this second video. I just want you to take a quick break, get yourself something to drink, a small snack, come back in a few moments, and do video number 3.